organic solvents. So the organic solvents is going to heat quickly, okay, before water boils. And then this organic compound is going to form a vapor. And that vapor will be passed by into some other process of steam distillations. And later on, the distilled solutions, which will be the solutions above the separating layer, will be collected and condensed for just having the pure solvent like before. Okay? So that's the process of 40 of steam distillation. So there are conditions. It means that steam distillation is not an effective method to separate immiscible liquids or inadmissible liquids. There are conditions should be obeyed for these steam distillations to be effective. Okay? So I'm going to teach you those conditions so that you will understand. Where are we using steam distillation to separate immiscible liquids, right? Okay. We have conditions now of steam distillation. So that's the next part. Conditions, say with me, conditions of 40 of steam distillation. Let me repeat. Steam distillations cannot be used to separate any immiscible liquid, right? It can separate all the immiscible liquids which obey the following conditions, right? Okay, so condition of steam distillation. Steam distillation of what? Of immiscible liquid. Don't forget that we are still learning about immiscible liquid, right? Immiscible liquids. So you have several conditions, but I'll mention 4, and then so look for the other conditions at the part of your advanced learning. The first condition we say that the organic solvent or the liquid, the organic solvent, let's say, the organic solvent that is required to be distilled, to be distilled by steam distillation, okay, by using steam distillation, right? Steam distillation should be or should be immiscible. Immiscible should be immiscible in water. Should be immiscible in water. This is the first condition. So organic solvents or the other liquids, especially in most cases the organic solvents, organic solution, organic solvent. So organic solvents that is required to be distilled by using steam distillation should be immiscible in water. So if it is miscible in water, steam distillation would be effective on separating those immiscible liquid. Again, we said that in the organic solvent, right? Organic solvent must be, this organic solvent must be volatile. Must be volatile, right? Must be volatile at a temperature, right? Temperature below 100 degrees centigrade. So the organic solvent, which you call it a second liquid forming the immiscible liquid, should be volatile. Should be volatile. It means this organic solvent must be forming, must have a capability or must have a property of forming a vapor, right? Below or at a temperature below 100 degrees centigrade. Why? Because remember our intention in steam distillations, we want this organic solvent, the solvent at the top of immiscible liquids, to be distilled. So in order to be distilled, we heat the whole solutions of what the whole mixture of immiscible water, liquid, or immiscible mixture. But this organic solvent will be forming vapor quicker or quickly rather than what? Water, right? So simply it should have capability or tendency of forming volatile at a temperature below 100 degrees centigrade. Again, the third condition we say that the organic solvent, in some of the references, instead of organic solvents, they use the liquid, the other liquids away from water, should be less dense than what? Than water. So why? In order for it to float above the separating layer. That's the third condition. The fourth condition, the organic solvents or liquid to be distilled must have a higher molar mass than molar mass of water. So the organic solvent, pure solvent, or the other liquid away from, different from water, should have the molar mass higher than the molar mass of water. So what the molar mass of water? We say that the molar mass, we just remind you, the molar mass of water, this we get it from this molecular formula, H2O. So then this will be 18 grams per mole. So the molar mass of the other liquid should be greater than the molar mass of water. Okay? Any questions at that moment? Any questions at that moment? Okay. If you have any question, ask it in the commenting section. Okay. So again, you have to look for the fifth conditions and the sixth condition. This is your homework. So find other two conditions for steam distillation, right? So next thing I have to teach you and show you how this process is carried out. So we say that the demonstration of steam distillation. So steam distillation. Okay, the diagrams of showing the steam distillation. Okay. So as we say that there are several stages that have to be taken in consideration. So now I'm going to draw for you how can we carry steam distillation in chemistry laboratory. Different diagrams, different sources. To one of them that you'll find is this. This we call it in chemistry conical flask. And then here we have source of heat. So this is heat. Heating this water. This is heat. Heating there. And this is inside, in this conical flask, we have water, so this is water, heated water, so heat water, okay, and then this is conical flask, so used to tight. This is simple representation of steam distillation. Then we have this pipe, and then this pipe is injected in another conical flask, of distilled the compounds, that the compounds are now we want to do the distillation process. Then this is another pipe or another tube. So this is the diagrams of this is the separating layer. So this is the organic solvents that we say that floats at the bottom or at the top of the separating layer. Hence this is water. Again here we have source of heat. Actually, if you're in chemistry laboratory, you can find that you get heat by using a Bunsen burner, which you learned during our O-level studies. So this is the one of applications of the Bunsen burner. This is the conical flux that I told you. Okay, so conical flux, and then here we cross by using the conical flux. Okay, and then again we have combinations of this tube at this point. And then this is the guide, but this is another way. Then we do have this, right? This is just for the purpose of condensation.